Hello everyone, and today we will see one fantastic question of thermodynamics of UPSC Civil Service question 2020. So let's start. So it is a piston cylinder friction device with linear spring attached with and spring constant, that is K value is given 100 kilonewton per meter, and cross section area of the piston is given 0.1 meter square. The cylinder initial volume, that is V1, is 20 liter, contains air at 200 kilopascal, that is initial pressure is 200 kilopascal, and ambient temperature is 300 Kelvin. That means ambient temperature, which is also initial temperature, it is 300 Kelvin, and a valve is connected, and there is a exist a stopper. These are the stopper which prevent the volume from exceeding 50 liter. That means the final volume V2 will be 50 liter. Now what happens? A valve connects a cylinder to an air supply line, that is a supply line 800 kilopascal and 325 Kelvin. A valve is now open and allowing the air to flow until the pressure in the cylinder will be 800 kilopascal. That means the final pressure, that will be P2. It will be 800 kilopascal and temperature is 350 Kelvin. So T2 will be 350 Kelvin. Now we have to find the and whenever this temperature and pressure attain, the valve is closed and process ends. And the final state, and in the final state, the piston reaches on the stop. That means piston reaches over here. Calculate the heat transfer during process Q. We have to find out. So here it is an unsteady state problem, and CP value 1.005, R value 0.287. It's okay, no problem. So initially, what happens here? It is connected with spring, linearly attached. Initially, no spring force is there. So initially, when you draw the free body diagram of piston, so there is a mg, and initial pressure is also given there, 200 kilopascal. So it will be P1 into A, and there will be atmospheric pressure is also exerting, P naught into A. So write down the equation first. So you can write is P1A is equal to mg plus P naught A. Equation number 1. Okay. Now when the pressure exerted and when this spring compress and reaches to this final state, so how much the displacement? X displacement is what? Initial volume, sorry, volume change V2 minus V1 is equal to spring force into, sorry, area into the height. Cross area is cross section area of piston. So V2 minus V1, that is 50 liter minus 30 liter, sorry, 20 liter. Initial volume is 20 liter. So 50 minus 20 liter, and we have to convert into meter cube. So 10 power minus 3 divided by the cross section area, that is 0.1. So you will get the X, this how much spring is compressed, X distance. So it comes out to be 0.3 meter. When you solve this, it is 0.3 meter. So that's this thing. So when the spring is compressed, so now how the force acting? Mg and Ps is, and here atmospheric pressure as well as spring force Ks, K into X. Okay. Now we can write PSA. Why S? Because I am writing as an intermediary pressure, Mg plus P naught A plus Kx. But Mg plus P naught is equal to P1A. So I can write as PSA is equal to P1A plus Kx. So PS will be what? So the PS will be P1 plus Kx divided by A. So let me find out the value of PS, intermediary pressure. That is, initial pressure is 200 kilopascal, spring constant K 100 kilonewton, and I will write in kilonewton. Why? Because I want pressure in kilopascal. X 0.3 meter, area 0.1, so it will be turn out to be 500 kilopascal. So mark my word, that is 500 intermediary pressure, 500. Why? Because final pressure is 800. So we can draw the graph PV diagram of this process like this: initial condition, intermediary and final condition. 1 to S to 2. Here the pressure will be 500 kilopascal and here 800 kilopascal, and here initially it will be 200 kilopascal. Volume will be 20 liter initial and final 50. So we can find out the work done during this 1 to S process, W, that is from the graph 1 by 2 into area of trapezium 200 plus 500 into 50 minus 20, but it is in liter, so multiply with 10 power minus 3. So when you do this, you will get 10.5 kilojoule. 10.5 kilojoule W. Just say it equation number 2 or result number 2. Now whenever this S state is reached, that means now volume will not increase but only the change of the mass flow will increase. So now from this state S22, it is unsteady state problem. Now it is unsteady state problem. So we have two equation for unsteady state. Delta M is equal to M inlet minus M exit, but here no mass is exiting, so and delta M will what? M2 minus M1 is equal to M initial, and M1 will what? M1 is equal to P1 V1 upon RT1. We have all the value P1 V1 RT1 from the upper side. You can just go back to the some few seconds, you will see the data, and you can find 0.064 kg, and M2 is what? P2 V2 upon RT2. We have all the value P, V, R, T at final state also, so you get 0.3982 kg. This M1 M2 minus M1 difference will give Mi. So put this all the value in this equation number 3. Now we have another equation. Change in internal energy will be MIHI plus Q minus MEHG, that means mass at exit, into enthalpy at exit minus work done. So exit mass is 0, so this term will be get cancelled out. Delta U will be what? M2 into specific internal energy minus M1 into specific internal energy. Mi, that is what? M2 minus M1 into Hi, H initial plus heat transfer that we have to find, and work done that we already find out. Now M2, U2 is what? Cv into T2, we know what is the U, and M1, U1 is what? Cv into T1 is equal to M2 minus M1 into H is what? Cp into T1 plus Q minus W. Okay, so we have all the value. M2 value we have 0.3982, CV, that is 0.718 into final temperature is 350 Kelvin, minus M1 is what? 0.0464 into 0.718 multiplied by initial temperature is 300 Kelvin is equal to M2 minus M1 0.3982 minus 0.0464. Cp is what? 1.005 given in the data, and it is 300 plus Q that we have to find, and W value we have 10.5 kilojoule. Sorry, let me write correctly. It is minus, because in equation that is a minus sign, so 10.5. So when you solve this, sorry for the bad handwriting, but I have to write fast because of the time limitation. So when you solve this, you will get Q in minus negative sign, minus 14.3 kilojoule. So this is the answer. For minus 14.3 kilojoule heat is rejected. So this heat is rejected from the system and amount is 14.3. So I hope you like this solution. First, it is a steady state process from 1 to S point. So we have solved according to the steady state, work done. Okay, and then it is converted to unsteady state problem. So we have two equation, mass balance as well as energy balance. We have used two equation for unsteady state and find out the heat transfer. So I hope you like this solution, and thank you for watching this video.